So in this session, we are going to solve a quadratic equation by using the method of factorization. Okay. So we are going to deal with the concepts that we will use in factorization. And there are a few techniques which would be useful over here. First of all, factorizing a trinomial is going to be of great help in this particular method. So we know that when we factorize a trinomial, we generally use the splitting the middle term technique, right? That is one common technique that is definitely used. And then you should also know that if you have a binomial, then always taking out common terms definitely helps, right? So taking out common terms is the basic idea in factorization. So let us understand what is the concept behind solving a quadratic equation by factorization. So if I have, say, two numbers whose product is 0, assume that I have a multiplied by b which is equal to 0, then this means that either a is 0, okay, that could be one option, or it could mean that a is 0, a is not 0, but b is 0, or it could also mean that a and b are both equal to 0, right? These are the different options that you can have when you claim that the product AB is equal to 0. So similarly, if I say that I have two terms which are equal to 0, so say this is x minus 3 and this is, say, x minus 2. If the product of these two is equal to 0, now if you notice carefully, this is actually the factorized form, right? So you will notice that if I expand this particular, if I expand these two terms, I will get x into x is x square, x into minus 2 is minus 2x, minus 3 into x is minus 3x, and minus 3 into minus 2 is plus 6. Or in other terms, the expanded form is x square minus 5x plus 6 equal to 0. But the factorized form is x minus 3 into x minus 2 is equal to 0, right? So x minus 3 into x minus 2 is my factorized form. Let us note it down. This is the factorized form. Whereas x square minus 5x plus 6 equal to 0 is the expanded form. Now, if the product of these two terms is equal to 0, then what we are going to do is, this would mean either x minus 3 is equal to 0, or it's going to mean x minus 2 is equal to 0, or maybe both of them are 0, right? That is also equally likely. Now, let's see what happens here. If x minus 3 is 0, then x has to be equal to 3, or x has to be equal to 2, right? Now, x cannot be 3 and 2 at the same time, which is why we drop the idea that x minus 3 is 0 and x minus 2 is 0. This idea gets dropped because x cannot be 3 and x cannot be 2 at the same time, right? So x can be either 3 or x can be either 2, and that is how we conclude that 3 and 2 are the roots of this particular polynomial. Now, I was able to come to this conclusion simply because the right hand side was equal to 0. So let me explain this further. Let's assume that I had, say, x minus 3 multiplied by x minus 2, say, equal to 6. Now there is no way by which I can conclude about the actual value of x. Why is that so? because there are infinite combinations of having the number equal to 6, like the product of the two numbers equal to 6. Maybe both the numbers are equal to root 6 and root 6, or maybe the two numbers are 3 and 2, or minus 3 and minus 2, or 1/6 and 36, right? There are so many combinations of getting the product of two terms equal to 6. However, if this right hand side is 0, as is the case in the given equation, right? In this particular equation, because the right hand side is 0, we know that there is a fixed form of predicting our numbers. If product of two numbers is 0, it means one of those two numbers has to be a 0. So this is the exact property that we exploit in the method of factorization. So what we are trying to do is we are trying to factorize the given quadratic polynomial, and we are always trying to keep the right hand side as 0 or the left hand side as 0. Basically, one of the sides of the quadratic equation has to be a 0. And because because after factorization the product of two terms is 0, you can conclude that one of those two terms has to be a 0, and from that you can find the roots of the quadratic equation, right? So this is the basic idea behind solving quadratic equations using factorization. So now let me take some problems and explain this in a better way. So consider these three examples. The first equation is 64m square minus 625 is equal to 0. The second equation is m square plus 8m is equal to 0. And the third equation is x square minus 13x plus 30 is equal to 0. Now, if you try solving these three equations, they are going to bring forward some unique ideas in factorization. Look at the first one. 64m square can be written as 8m the whole square minus, I know that 625 is 25 square is equal to 0. So using the idea of a square minus b square, I can say that a plus b times a minus b has to be equal to 0. If the product of two terms is 0, it means that one of the two terms has to be a 0. So this implies either 8m plus 25 is 0 or 8m minus 25 is equal to 0. Which means m is equal to minus 25 by 8 or m is equal to, I can shift the 25 to the other side and then divide it by 8. So m is either minus 25 by 8 or m is equal to plus 25 by 8. These are the two roots of the given quadratic equation. So what was the concept that I used in this particular question? The concept used here was a square minus b square was written as a plus b multiplied by a minus b, right? So there's another way of solving the same question, which I'm going to show you now. Say I can also solve this as 64m square is equal to 625. That is shifting the 625 to the other side. Or I can say m square is equal to 625 divided by 64. Taking the square root, I get m is equal to square root of 625 by 64, which means m is equal to plus or minus root of 625 is 25 and root of 64 is 8, right? Therefore, the value of m is either plus 25 by 8 or minus 25 by 8. Because we are in the 10th standard now, we need to understand that taking square roots leads to two possible answers and not just one answer. And this is how we could solve the first question. So let me again pause for a minute before I move on to the second one. Okay, moving on to the next question. So in the second question, this is a binomial, but here I need not use a square minus b square. Rather, I cannot use it here. What I will do is I will simply take m out as common. So m bracket m plus 8 is therefore equal to 0. Now if product of two terms is 0, it means either m is 0 or m plus 8 is equal to 0. And this implies the solution is m is equal to 0, or shifting the 8 to the other side, it becomes negative 8. And therefore, the solution set of this quadratic equation is 0, negative 8, right? So when I have a binomial and I cannot use a square minus b square there, simply taking out terms as common is also one useful technique. Let me now move on to the next one. Now this is a trinomial, and we should use splitting the middle term technique over here. So what does the splitting the middle term technique say, or factorization of trinomial say? You look at the coefficient of the two extreme terms. So x square's coefficient is 1 and the constant is 30. So 1 into 30, this will be the product. So the product of the two terms is 30, positive 30. And the sum is the middle term. So the middle term is negative 13, right? And therefore, we have to now find two numbers whose product is positive 30 and sum is negative 30. Now the product is positive means that either both the numbers are positive or both the numbers are negative. And negative sum indicates that both the numbers have to be negative, right? Because if one is negative and the other is positive, the product would become a negative number. So product is 30 and sum is negative 13, indicates both the terms are negative. Now let me start making my tree. So what I do is I start with the product, and now let's start splitting it in factors. So 30 can be written as 30 ones are, but these two terms will not give me a sum of minus 13. It is also 15 twos are, but if I see, I cannot get a sum of negative 13 because minus 15 and minus 2 will give me minus 17. The next option is 10 threes are, and I notice that yes, this is the right option because negative 10 and negative 3 will become negative 13, and negative 10 into negative 3 will become positive 30. So this is definitely a very good option for splitting the terms. So I get x square. So I get x square minus 10x minus 3x plus 30 is equal to 0. Now what is common in these two terms? X is common. So I pull it out. I get x into x minus 10. And in these two terms, minus 3 is out. So minus 3 times x minus 10 is equal to 0. Which means x minus 3 multiplied by x minus 10 is equal to 0. Now because the product of two terms is 0, one of them has to be a 0. Which means either x minus 3 is 0 or x minus 10 is 0. And therefore x is equal to 3 or x is equal to 10. And therefore the solution set is 3, 10. If you substitute x as 3 or x as 10 in this particular quadratic equation, the quadratic equation will be satisfied. That is the meaning of the solution set. Now, so let's quickly check if this is true. Let's take the equation written there, x square minus 13x plus 30 equal to 0. Let's substitute x as 3. So 3 square is 9 minus 13 nines are 13 threes are 39 and plus 30 equal to 0. And yes, 0 is equal to 0. So 3 definitely satisfies the equation. Substitute x as 10. So 10 square minus 13 into 10 plus 30 equal to 0. 10 square is 100. 100 plus 30 is 130. 130 minus 130 is 0. So yes, the number 10 also satisfies this quadratic equation. And therefore we can see that in this particular slide, we saw that there are three techniques that could be used. One is the a square minus b square. The other technique is simply taking out terms as common, and then factorizing the trinomial is a great way to solve quadratic equations. So I'll pause for a minute and then I will take up some more questions from factorizing the quadratic polynomial. Okay, let's consider solving the following quadratic equations. Let's take a look at the first one. We have x square plus 6x plus 5 equal to 0. So now we need to split the middle term. Let's look at the two extreme coefficients. We have 1 and we have 5. So I need two numbers whose product is 5 and the sum is 6. So let me start with the product as 5. So 5 can be written as 5 ones are 5. And it's great that 5 plus 1 is equal to 6. So we got the right way to split. The right way to split 6x is going to be 5x and 1x. So let us split it now. So x square plus the 6x can be written as 5x plus 1x, right? Plus 5 is equal to 0. And now I can take x common from these two terms. So x bracket x plus 5. And in these two terms, only 1 is common. So 1 bracket x plus 5 is equal to 0, which means x plus 5 multiplied by x plus 1 is equal to 0. Now if product of two terms is 0, then it means that either x plus 5 is 0 or x plus 1 is equal to 0. Which means x is either negative 5 or x is negative 1. Therefore, the solution set of this quadratic equation is negative 5, negative 1. So you will notice that I always start with the product and I try to find the right factors, and wherever I get the right sum, that is where I stop and I use those numbers. Now here this 6x was being split as 5x plus x, which tells us why this method is called splitting the middle term, because the middle term over here, which is 6x, was split as 5x plus x. So this is how we solve this particular question. Let us now go to the next one. We have x square, 8x square minus 22x minus 21 equals 0, right? So the equation is 8x square minus 22x minus 21 is equal to 0. So again, let us find two numbers whose product is, take the extreme terms, 8 and negative 21 is negative 168 and the sum is negative 22, right? So the product is negative means one of the terms is negative and the other term is positive, and the sum is negative means the bigger number is negative, right? So let's take negative 168 and let's start splitting it. Negative 168 can be split as 84 2s are not working, 42 4s are not working. Let's now see if so now what I will do is, I will divide this number by 2, right? So dividing it by 2, I get 21 and I will multiply this number by 2. So when you divide one side by 2 and multiply one side by 2, the product remains constant. But unfortunately 21 and 8 is still not working for us. Okay, no problem. Now what I'm going to do is, I'm going to split this into factors, that is 7 3s are, and split 8 also into its factors, which is 4 2s are. Now let us see if some merging of numbers here. So now I have to play with these numbers. I notice that if I take 7 4s are, it is 28 and 3 2s are is 6. So I get 28 6s are. This is the right combination which will give us a sum of negative 22. So I will take it as negative 28 and positive 6. So essentially what I did here was, because I was not able to find the right factors, I split the factors further. 21 was split as 7 3s are, and 8 was split as 4 2s are, and then I tried merging some factors so that I could get a sum of negative 22, right? Therefore, 7 4s are 28, 6 are 28 and 6 definitely have a difference of 22. Now the sum should be negative, which means that the bigger number is negative. So negative 28 and 6 is the right combination. So what I get here is 8x squared plus 6x negative 28x negative 21 is equal to 0. What is common in these two terms? 2x is common. And what is left inside? 4x plus 3 is left inside. From these two terms, what is common? Minus 7 is common, and 4x plus 3 is left inside, is equal to 0, which means 2x minus 7 multiplied by 4x plus 3 is equal to 0. Now if product of two terms is 0, it means that one of the two terms has to be a 0, which means 2x minus 7 is 0 or 4x plus 3 should be 0. This would imply x is equal to, take the negative 7 to the other side, so you get 7 by 2, or x is equal to, take the 3 to the other side, negative 3 upon 4. This is the solution set for the given quadratic equation. So this is how we use splitting the middle term technique. Let me pause for a minute before I pick the next two problems. Okay, moving on to the next two questions. So the next equation we have is 9x square minus 3x minus 2. 9x square minus 3x minus 2 equal to 0. Again, the product over here is, let's take the extreme terms. 9 into negative 2 is negative 18 and the sum is negative 3, right? So now we have to split the two terms. Let's split 18. 18 is 9 2s are, but that doesn't give me a sum of 3. Or 18 1s are, no, that is also not working. Or 6 3s are. I believe this is going to work very well. So product is negative 18 and sum is negative 3 means the numbers are negative 6 and positive 3. Therefore, I can split these terms as 9x square. Negative 3x can be written as negative 6x positive 3x minus 2 is equal to 0, right? So this is how I can split these middle terms. Taking these two terms, I can take 3x out as common. So if I take 3x out as common, I am left with 3x minus 2. And from 3x minus 2, I can take 1 out as common. So it is 1 times 3x minus 2 equals 0. I can take a 3x minus 2 out as common and I am left with 3x plus 1 is equal to 0. Now you will notice that the product of these two terms is 0, which means one of these two terms has to be a 0. So either 3x minus 2 is 0 or 3x plus 1 is equal to 0, which means x equals 2 by 3 or x equals negative 1 by 3, right? So therefore, the solution set is 2 by 3 or negative 1 by 3. This is the solution set, right? Now I can pick up the next question also, which is x square minus 13x plus 30 equal to 0. So over here, again, what is the product that I want? The product that I desire is 1 multiplied by 30, that's 30. And the sum that I want is negative 13. So I can split 30 into its two parts. 30 ones are, but that doesn't give a sum of negative 13. Or 10 threes are. I believe 10 threes are works really fine. So I can write this as x square minus 10x minus 3x plus 30 equal to 0. What is common in these two terms? It is x. So I am left with x minus 10. And in these two terms, minus 3 is common. So I am again left with x minus 10 equals 0. In these two terms now, x minus 10 is common. And I am left with x minus 3 inside. So if the product of these two terms is 0, it means x minus 10 is 0 or x minus 3 is equal to 0. So if x minus 10 is 0, it means x is equal to 10 or x is equal to 3. And therefore, I can say that the solution set is given by 10, 3. These are the two solutions of the given quadratic equation. So again, let me pause for a few seconds before I move on to the next question. Okay, moving on to the next set of questions. The next equations are 49x square minus 1. So we have 49x square minus 1 is equal to 0. And x plus 35 upon x is equal to 12, right? So what I can do here is 49x square can be written as 7x the whole square minus 1 square is equal to 0. So definitely I can use the form a square minus b square equals 0, which means a minus b into a plus b has to be equal to 0. If product of two terms is 0, I know that either 7x minus 1 is 0 or 7x plus 1 has to be 0. So 7x should be equal to 1 or 7x should be equal to minus 1, which means x is either 1 by 7 or x is equal to negative 1 by 7, right? So this is one way of solving this question. Let me show you another way of doing this. I can also write 49x square is equal to positive 1 by shifting the negative 1 to the other side. So therefore x square is 1 upon 49, which means x is the square root of 1 by 49. Now square root of 1 by 49 is 1 by 7 and that's plus or minus, right? Therefore, the solution set is either positive 1 by 7 or negative 1 by 7. This is the final answer. Now let's try solving the second one. Over here, it looks like I should take the LCM, right? And again, remember, generally for factorization problems also, writing it in the standard form is definitely recommended because then it helps in the process of factorization. The LCM here is now x. So 1 multiplied by x. So x multiplied by x gives you x square plus 35 is equal to 12, right? The x goes to the other side for multiplication. So we get x square plus 35 is equal to 12x. Shifting the 12x to the left hand side, we get x square negative 12x plus 35 is equal to 0. So now this has been written in the nice standard form, and therefore the product is going to be 1 into 35, that's 35, and the sum is going to be negative 12, right? Therefore, let us now find two numbers with product of 35 and sum of 12. Let's write 35. Let's split 35, can be either 35 ones are, or it can also be 7 fives are. Now 35 ones are will never give a sum of 12. So the only possibility is 7 and 5. So the sum is negative, and therefore I would have negative 7, negative 5. Therefore I can say that the numbers are negative 7 and negative 5. So x square negative 7x negative 5x plus 35 is equal to 0. In these two terms x is common, so x into x minus 7. In these two terms minus 5 is common, so minus 5 into x minus 7 is 0, which means x minus 5 into x minus 7 is equal to 0, which means either x minus 5 is 0 or x minus 7 is 0, and therefore I can say that the solution set of this particular quadratic equation is 7, 5, right? So the solution set is therefore 7, 5, or you can write it as 5, 7 also, right? So this is how we solved these two quadratic equations. Again, pausing for a minute before I move on. Moving on to the next set of questions. So consider these two equations now. In these two terms, I can definitely take something out as common. In 16 and 24, 8 is common. And in x square and x is common. So let's pull it out. Let's see what is left inside. From 16 I have pulled 8 out, so 2 is left inside. From x square, x is pulled out, so x is left inside. Minus, from 24, 8 has been pulled out, so 3 is left inside and x has been pulled out. So this becomes equal to 0, which means either 8x is 0, or I can say that 2x minus 3 is equal to 0, which means x is equal to 0, or x is equal to 2x is equal to 3, which means x equals 3 by 2. And therefore, the solution set can be written as 0, 3 by 2, right? This is the final answer. Now let's consider the case of x square minus 8x plus 16 equal to 0. Again over here you will notice that this is a trinomial. So product of two terms is 1 into 16, that's 16. And sum of the two terms is negative 8. So now we should find two numbers whose product is 16 and sum is negative 8. Of course, 16 ones are is an option, but that doesn't give me a sum of 8. Or I can also try 8 twos are, but 8 twos are also doesn't give me a sum of 8. Or I could also try 4 fours are, and I think 4 fours are will give me a sum of 8. The product is positive and the sum is negative, which means both my numbers have to be negative. So I can say x square, I can split this negative 8x as negative 4x plus 16 equal to 0. This is why it is called splitting the middle term. The middle term was split as negative 4, negative 4. And now what is common in these two terms? X is common. And let's see what is left inside, x minus 4. In these two terms, minus 4 is common. And therefore, x minus 4 is left inside. This means x minus 4 multiplied by x minus 4 is equal to 0. And therefore, x minus 4 is equal to 0. Or x minus 4 is equal to 0. Which means x is equal to 4 or x equals 4. And therefore, the solution set can be given as 4, 4. Or you can also write this as 4. But because this is a quadratic equation, we have two roots. We know that every quadratic equation has two roots. Now in this case, the roots happen to be real, but we still mention it as 4, 4, right? This is the preferred way, though there is nothing wrong with x equal to 4. But this gives us an impression that it is a linear equation because only one root was specified here. Now in this example, 16x square minus 24x equal to 0, you will notice that both the roots are real. Both the roots are real numbers, right? But the roots are distinct. Therefore, these roots are real and distinct. They are different from each other. Whereas in the last example that we took, x square minus 8x plus 18 equal to 0, you will notice that these roots are real. Yes, they are real, but both the roots are equal. Therefore, these roots are real and equal. So real and distinct roots mean the roots are real, but they are different from each other. Whereas real and equal roots mean the roots are real and they are also equal to each other. Right? So this is how we go about these questions. Let me again pause for a minute before I move on. Okay, let us take a few more questions based on factorization. So let us consider these three equations now. Let's start with the first equation. So we have 3x squared minus 2 root 6x plus 2 equal to 0. So what is the product that you desire here? The product is 3 multiplied by 2, that is 6. And what is the sum that you desire here? The sum is the middle term, which is minus 2 root 6. So now we have to find two numbers whose product is 6 and the sum is negative 2 times root 6, right? So what I'm going to do is, first, because the sum is 2 root 6, it looks like both the terms might contain a root 6. So that is a sort of hint for me. So if I take the number 6, I can split it as 3 and 2. But please understand that 3 and 2 are natural numbers. They will never give addition of a third, right? So what I'm trying to tell you is, why not split it as root 6 and root 6? Let us see if this works. What is root 6 multiplied by root 6? Root 6 multiplied by root 6 is 6. So the product condition is satisfied. And I want sum as negative 2 root 6. So what will happen if I apply a negative sign to both the numbers? Negative root 6 into negative root 6. So minus into minus is plus, and root 6 into root 6 is 6. So the product remains positive 6, which is satisfied. And negative root 6 is minus 2 root 6, which is what I want in the sum part, right? So the right way to split it is negative root 6, negative root 6. So I get 3x square negative root 6x negative root 6x plus 2 equal to 0. Now let's see what is common. Okay, now be careful here. See, this 3 can be written as root 3 multiplied by root 3. Then I have a x square minus root 6 can be written as root 3 multiplied by root 2 times x. Why am I doing all this? Because I am trying to see which factors are common to these two terms. Minus root 6 can be written as root 3 multiplied by root 2 x, and 2 can be written as root 2 multiplied by root 2 is equal to 0, right? Now let's see what is common in these two terms. In these two terms, root 3 is common, so let's pull it out. Which is why I wrote this 3 as root 3 into root 3, right? Because you wrote it as root 3 into root 3, you see that a root 3 is common. X square can be written as, so between x square and x, 1x is common. Let's see what is left inside. I have pulled the root 3 out. From x square I have pulled x out. So root 3x is left inside, minus. I have pulled the root 3 out. I have pulled the x out. So root 2 is left inside, minus. From these two terms, you will notice that root 2 is common. So let's pull it out and let's see what is left inside. I have pulled root 2 out and this root 2 out. So I am left with root 3 into x, that's root 3x. From the positive sign I have pulled out a negative sign, so the sign flips. I have pulled out 1 root 2, so 1 root 2 is still left inside. To make it easier, let me just strike out the terms that are taken out as common. Root 3 was taken out as common. Root 2 and root 2 was taken out as common, and 1x was taken out as common from these two terms. Now let's see what is left inside. You will have root 3x minus 2 is common in both the terms. So this is root 3x minus root 2 times root 3x minus root 2 is equal to 0. Therefore, I will get either root 3x minus root 2 is 0, or I can say that root 3x minus root 2 is equal to 0, which means x is equal to root 2 divided by root 3, or in this case also root 3x is equal to root 2, which means x is equal to root 2 by root 3. And therefore, the solution set can be written as root of 2 by 3, comma root of 2 by 3. You will notice that these roots are real and they are equal to each other also, right? Hence, the nature of the roots here is real and equal. Alright. So what I want you to understand is, whenever you see such surds in the quadratic equations, don't be worried about them. Just try to understand of how this particular splitting was done, and more importantly the factorization part, right? So again, let me pause for a few seconds before I move on. Okay, let us now solve the second question. The second equation is x square plus 2 root 2x minus 6 equal to 0. So these two numbers will basically, what is the product that we want? 1 into negative 6. So the product desired is negative 6 and the sum desired is positive 2 root 2, right? So this is a hint that the number should definitely contain root 2. So what I'm going to do is, I'll take the number 6 and let me split it as root 2 and root 2. Now, root 2 into root 2 gives me a 2. But what is the product that I want? The product that I want is 6. So I have root 2 into root 2 is 2. I am now falling short of 1, 3 over here, right? So what I will do is, I will apply that 3 to one of the two terms. So let's apply a 3 here. And now let's think about the signs. So I want the product as negative, which means one of these two numbers should be negative. And I want a positive sum. Positive sum basically means the bigger number is positive and the smaller number is negative. Let's check if the product is 6 now. So root 2 into root 2 is 2 and 3 into 2 is 6. So the product is negative 6. That's right. And 3 root 2 minus root 2 is 2 root 2. So the sum condition is also satisfied. So this is how I try to find the right middle term. So x square plus 3 root 2x minus root 2x minus 6 is equal to 0. In these two terms, x is common. So I get x bracket x plus 3 root 2. And then I have minus root 2x and 6 can be split as 3 into 2 is equal to 0. So x into x plus 3 root 2 minus root 2x minus this 2 now can be written as root 2 into root 2 is equal to 0. Why did I do this? I did this because again root 2 is common in these two terms. So x into x plus 3 root 2 and from these two terms minus root 2 is taken out as common. So I am left with x plus 3 root 2 is equal to 0 and therefore what I get is x plus 3 root 2. You will now notice that x plus 3 root 2 is common in both the terms. So x plus 3 root 2 into x minus root 2 is equal to 0. Product of two terms is 0 means one of the two terms should be a 0. So either x plus 3 root 2 is 0 or x minus root 2 is 0, which means x is negative 3 root 2 or x is equal to positive root 2. These are the two roots of the given quadratic equation. So again, let me pause for a few seconds before I move on. So let us now go to the next question. So consider this question now. We have root 3x square plus 10x plus 7 root 3 equals 0. Let us find what is the product. So the product is, take the extreme terms, that's root 3 multiplied by 7 root 3, which is going to be 7 3s are 21, and the sum is positive 10. So find two numbers whose product is 21 and sum is positive 10. So 21 can be split as 21 ones are, but that won't give a sum of 10. Or it can be split as 7 3s are, and 7 plus 3 is indeed 10, right? So I think this is the right combination. So let us write it down now. Root 3x square plus 3x plus 7x plus 7 root 3 is equal to 0. Now in the first two terms, let us see what is common. It looks like nothing is common, but wait. Why don't we write this 3 as root 3 into root 3? So root 3x square plus 3 can be written as root 3 into root 3 x plus in these two terms 7 is common. So 7 bracket x plus root 3 is equal to 0. Now in these two terms what is common? Root 3 is common and x is common. So I pick root 3 out. From x square I pick x out. So x is left inside. Plus root 3 is taken out. X is taken out. So x plus root 3 is left. Plus 7 times x plus root 3 is equal to 0. Now what is common in these two terms? X plus root 3 is common. Bracket root 3x plus 7 is equal to 0. So now if product of two terms is 0, I know that x plus root 3 is 0 or root 3x plus 7 is equal to 0. This means x is equal to negative root 3 or root 3x is equal to negative 7, which means x is negative 7 by root 3. Now I can write the solution set as either minus root 3 comma negative 7 by root 3, or I can also decide to rationalize the denominator here. So let me go ahead and rationalize the denominator of negative 7 by root 3. So I have negative 7 by root 3. I will multiply by root 3 and divide by root 3. So I get negative 7 root 3 upon root 3 into root 3 is 3. And therefore the solution set can also be written as negative root 3 comma negative 7 root 3 upon 3, right? So these are the different ways of writing the solution set. But what I want you to observe here is, or understand from these examples is, if you notice square roots in your sum and product, don't be worried. Try to find the right combinations and use the right factorization techniques. So we conclude with our session over here. I will pause for a minute and then we conclude today's session.